Welcome to Math with Mrs. Bibb. Today I will be reviewing material from the first summer work assignment and adding new material that's review and or new concepts from either 8th grade math or what you will be learning in Algebra 1. So if you'll grab a pencil, piece of paper, and write down what I write down, you'll earn yourself some extra credit. Here we go. So first, these first 6 questions are just review, so I will talk through them as I work them out. The first thing I'm going to do on number 1 is distribute. When I distribute, I have 88 equals 2m plus 16 plus 7m. Next, I'm going to combine like terms. 2m and 7m are on the same side of the equal sign, so those would be considered like terms. So I just combine them together to make 9m. Then I want to get this alone. I'll highlight it. I want to get 9m alone. So what's keeping it from being alone is the plus 16 and the plus 16. So I will subtract 16. So I will have 8 minus 6 is 2, 8 minus 1 is 7, 72 equals 9m. I'll divide by 9 to get m alone, so m equals 8. And these are all the steps that I would expect to see you do, except for the highlighting, of course. But that's what I expect to see on your paper when I check your summer work assignment. Okay, we'll go on to the next one. We're going to distribute. 252 equals 4 plus 24 plus 28p. Then I am going to combine like terms. The 4 and the 24 are like terms on the right side of the equal sign. So 252 equals 28 plus 28p. Next, I want to get the 28p alone. So I'm going to subtract the 28 from both sides. I don't know what that is off the top of my head, so I'm going to bring down the 28p. This is going to be 12, and this will be 4. So 12 minus 8 is 4. 4 minus 2 is 2. And bring down the 2. So 224. Divide both sides by 28. And I don't know how many times 28 goes into 224, but let me think about it. I need to multiply by something and it ends in a 4. So maybe 8, 28 times 8, because 8 times 8 is 64. 28 times 8, 8 times 8 is 64. 8 times 2 is 16, plus 6 more is 22. So yes. So P will equal 8. That's the answer to number 2. For number 3, I'm going to distribute on both sides. Negative 6 minus 48a equals 48a minus 6. I am going to move the 48a on the left to the right, the negative 48a on the left to the right by adding 48a. So negative 6 is going to equal 96a minus 6. I'm going to add 6 to both sides. Negative 6 plus 6 is 0, so 0 equals 96a. Divide by 96. A will equal 0. For the next one, I'm going to distribute on both sides again. 6 times x is 6x minus 48 equals negative 3x minus 3. Next, I will add 3x to both sides. I want to move the variable on the right to the left. You could do vice versa. It doesn't matter. It's really up to you. 6x plus 3x is 9x minus 48 equals negative 3. So I have to, on this next step, to add 48 to both sides. So remember, when I'm doing this and marking these out, like here on number 4, and then on number 3, negative 48a plus 48a, I marked that out. I didn't mark it out, but I went back and marked it out. And here on number 2, 28 minus 28, I marked that out. And on number 1, plus 16 minus 16, mark that out. Those are making 0. So I'm doing the inverse operation to make 0. And then when you get to this next step, 9x equals negative 45, you want to get x alone. It's being multiplied, so you divide to get it alone. So that's those inverse operations. So x equals negative 5. Negative 5 times 9 is negative 45. For the next one, and these were probably new for you, remember we are going to multiply these two, set it equal to these two being multiplied. Doesn't matter which side you put those on to start with, but that's what we're going to do. So r times 10 is 10r equals 2 times r plus 6. I'm going to distribute, so 2 times r is 2r. 2 times 6 is positive 12. Next, I'm going to subtract 2r. So 8r will equal 12. Looks like I'm going to get a decimal. Subtract 2r. 10 minus 2 is 8. Yep, it's okay. I'm not going to get a decimal. I'm going to get a fraction because I'm not going to use a calculator. And then 12 over 8 reduces to, both divisible by 4, reduces to 3 over 2. So r is 3 over 2. That's my answer. And for the next one, we're going to do the same thing. We're going to multiply p plus 2 and 8. And then we're going to write down an equal sign and multiply 9 and p. So 8 times p plus 2 equals 9 times p. So 8p plus 16 equals 9p. I'm going to subtract that 8p. So 8p minus, 9p minus 8p on the right-hand side of the equal sign is just 1p or p, and you're left with 16 on the left. So p is 16. And that is those review questions. I believe the next slide has some review questions also. Yes, we are drawing on a number line. So I'll draw a number line for this one, draw a number line for this one. I will put 0 on my number line, and then I'll put positive 3 because that's the number that's here. This tells me to put a solid circle, and where a number is greater than 3, to the right. And then for the next one, I'm going to put 0 on my number line, and then I'm going to put positive 1 to the right of it. It is equal to, so I'll put a solid circle and shade to the left. That's where numbers are less than 1. Remember, if it's less than or greater than, that's an open circle. If it's less than or equal to, greater than or equal to, that's a closed circle. So open, closed. Okay, for the next one, I'm just going to use x as my variable. You can use whatever variable you want. So I know this first one is going to be equal to, and 2 is going to be there. The second one is not going to be equal to because it's open, and negative 2 will be here. It's shading to the left, so that's less than or equal to 2. And this one is shading to the right, so that's greater than negative 2. So those are your review questions there. I hope that helps you with these questions from your assignment. Okay, so on to the next thing. Now we're going to use each table or graph and name the domain and the range. And I want to make a couple of notes first, and if you'll please make sure to write these down. The domain is the set of x values. And it's how far left or right a graph goes. And I'll do that in red. I'm going to switch colors, and I'll do green. The range is the set of y values. So if you just have like number 11 and 12, if you just have a table, then you just write the set of x values. So x's on the left, and the range would be the set of y values. Those are on the right. Those are our domain and range with the correct corresponding color. And we'll write those properly in just one moment. But when you have questions like 13, 14, 15, and 16, you need to use how far left or right a graph goes and how far up or down. And I'm going to go through and highlight the graph. So I think I'm using red right now. So how far left or right? That's going to be your domain. And how far up or down is going to be the range. How far up or down? Okay, so let's go back to number 11. The domain for number 11. You should put them in numeric order from smallest to largest. So -7, 1, 3, 4, 5. They should be surrounded by braces. That is the domain. It's the set of x values. The range is the set of y values. You should put them in order from smallest to largest with a comma between each one. I think I got them. -4, 0, 1, 2, and 4. So that's the domain and the range. And then for number 12, the domain, -6, -2, 4, and 7. -6, -2, 4, and 7. Notice I did not repeat that -2. You do not repeat values that you have that are the same. You only need one of them in your list of x values. And then for the range, I would have -5, -3, -2, 0, and 6. Those would be my range values. Now, I want to look at every one of these graphs. Let's look at the domain first. Domain is how far left or right a graph is going. Now, if you look at these arrows, this graph is going forever to the left. So hopefully you see that. Domain is your x, range is your y. So don't forget, domain is x, range is y. Now, since my graph is going forever to the left, it's going to be less than. I'm going to have to erase so we can look at something. And then I got to look, oh, maybe it won't let me erase. Nice. Oh, that's okay. I've got to look at, I think it was closed. So if you remember and I am incorrect, just let me know. I'm pretty sure it was closed. I think I can go look at another source that I have really quickly to see what it looks like. So I need that ordered pair to know how far left or right it goes, because that would be my furthest point to the right on that graph, on that blue sideways V-shaped graph. That would be the furthest point on the right. So we need to know what that is. And yes, number 13 is solid, number 14 is open, 15 is solid, and 16 is open, and we can tell that. Okay. Solid in both places? Yes. Okay. So this ordered pair, I'm so sorry you can't see it. This ordered pair here is negative, oh wait, sorry. How far left or right do you go to get to this point? Well, you go 0, left or right, and you go down 2. So 0, negative 2. Now, x, y, domain, range. Well, and you're not necessarily going to use that value for your range. We'll talk about that in just a moment. So my smallest x value is 0. So x is less than or equal to 0 because that is a solid circle there. Now for my y's, how far up or down does this graph go? Well, it goes forever up and it goes forever down. When it goes forever up and forever down, then the range and or the domain, if it goes forever left and right, then your range is all real numbers. Now, for number 14, does this graph go forever left and forever right? Well, if you look at it, the blue graph only goes to the left 4, and that's the only place it is, all the way up and down. All the way up and down through here, it's only going to the left 4. So every one of my x values on that graph are 4. The domain is 4. That's it, just 4. Now, for my range, does this thing go forever up and down? Just like the one on the left, number 13 went forever up and it went forever down. This one goes forever up, not down. So I know my range is going to be y is greater than, because it's going up, and then I need to know the smallest y value on that graph. Well, this ordered pair here is, start from the origin, left 4, down 7. Left 4, down 7. So my smallest y value is negative 7. So y is greater than negative 7. Okay, number 15. Does this graph go forever to the left and to the right? And I'm looking at the actual problem, and it starts here at 6, and it goes forever to the left. So it does not go forever to left and right, just to the left. So my domain is going to be x is less than or equal to, less than because it's going to the left. If it was going to the right, it'd be greater than. Equal to because this is a solid circle. And then what is that ordered pair? I go to the origin, go right 6, go nowhere up or down. So x is less than or equal to 6. That's the biggest x value for that graph. And then for my range, is it going forever up and down? No, it's going forever down. So y is going to be less than or equal to 0. 0 is the biggest y value, and they only decrease from there, going down. Let me show you. I was drawing and you couldn't see. 0 is your biggest y value, and then they only decrease from there. Like here, y is negative 2. Here, y is negative 4. Here, y is, whatever that is, negative 8. So these y values are decreasing forever. So that's the domain and the range. Number 16. Now for number 16, does this graph go forever left and forever right? Well, hopefully you can tell from this arrow. Let me go back to my pen. From this arrow, it is going forever to the right, but it does not go forever to the left. The furthest left it goes is this ordered pair right here, which is negative 3. Go to the origin, go left 3, up 2. So negative 3, positive 2. So the smallest x value, so my domain, x is greater than or equal to, because it's going forever to the right, so it's greater than or equal to negative 3. And then for my range, is it going forever up and down? No, it's just going forever up. So the lowest y value is going forever up. So greater than, y is greater than. It's just greater than because this is an open circle. And what is that ordered pair? You go start to the origin, you go right 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. So -5, -6 is this ordered pair. We're talking about the range, so -5, -6. That is the range for that one. Now for number 11, it asks if these are functions, and all we have to do is write yes or no. To be a function, I'm going to write that, hopefully, or you should write that as well. To be a function, it has to meet some conditions. First of all, no x values can repeat if you have a table. And second of all, if you have a graph, it has to pass the vertical line test. Okay, so for number 11, let's look at it. Do any of my x values repeat? No, then it is a function. So yes, function. Number 12, do any of my x values repeat? Yes, -2 repeats. So no, number 12 is not a function. Number 13, if you drew vertical lines, that each vertical line can only pass through that graph one time. I'm going to switch to yellow. So if I drew vertical lines, here I would be good because it only goes through that point. But look here, it fails the vertical line test. So no, that's not a function. Number 14. Number 14 is a vertical line. So it fails the vertical line test. No, it is not a function. Number 15, would this pass the vertical line test? Every yellow line that I'm drawing is only going through one point on that graph. So yes, it is a function. And how about number 16? Fails. It went through that graph twice. So no, number 16 is not a function. And going on to the next slide. So for number 18 and 19, we want to find out what is the independent and what is the dependent variable in these problems. And I want you to remember y depends on x. So y is dependent, x is independent. So if you can figure out what depends on what in the problem, then you can know which one is independent and which one is dependent. So Helen's child is a musician that will be participating in an upcoming concert. For each piece of music played, her child will need to practice a certain number of hours to perfect their part. Let n be the number of hours her child needs to practice. So n is practice hours. And P is the pieces that will be played. P is the pieces that will be played. Okay. For each piece of music played, her child will need to practice a certain number of hours to perfect their part. So the amount of practice depends on the number of pieces, right? So this is work you could show. You don't have to write the problem, just that could be your work. Write N as practice hours, P is pieces that will be played. So the practice depends on the pieces. So Y depends on X. And I know we have different variables over here. So then I know that N, because practice is in this problem, N depends on P. So my independent variable, So we'll just write that above it. My independent variable, I don't think I wrote that correctly, hold on. Independent variable is the number of pieces, and the dependent is hours of practice. So that's what I needed to know. That was what the instructions asked, so we are finished with that one. Number 19, Joy is planning a party. The number of invitations she orders is determined by the number of friends she wants to invite. So F is the number of friends. And I is the number of invitations. Invitations. Okay. So the number of friends, number of invitations depends on number of friends she wants to invite. Invitations depends on friends. So independent is the number of friends. Dependent is the number of invitations. So we're going to write that out. Independent variable is the number of friends. Oops, left off my R. Number of friends. And dependent variable is number of invitations. Okay, that's all of that one. And again, you did not have to write all the words. The words that I have written in green are sufficient. And number 20. So not only do we have to name the independent and the dependent variables, we have to find the range given this domain. Okay, so let's do the independent and dependent variables first. Independent and dependent. Number of cups of flour left in a bin after making batches of brownies. After B batches of brownies. Y equals negative x plus 10. That's how I look at that. So y depends on x. So F is, so the cups of flour. Flour depends on batches of brownies. So y depends on x. So dependent is the number of batches of brownies. And independent is the cups of flour left. I was about to spell that wrong. Flour. Cups of flour. Oh, what if I can erase? Yep. Cups of flour. Okay, now I'm going to make a chart. That's what you should do. So working on making a chart, I will put my domain or my x values here, and then my range or my y values will be here, and my function will go in the middle. And so I have 1, 2, 3, 4. That's my domain. 1, 2, 3, 4. And these are my B. This is the B values. And this would be F. So F is going to be negative 1 plus 10, which is 9. F is going to be negative 2 plus 10, which is 8. for the third one. And you'll have lines on your paper. I'm going to go ahead and separate these so it's easier to see. F is going to be -3 plus 10. So that's 7. And for the last one, F is going to be -4 plus 10, which is 6. So my range, this is my final answer, my range is 6, 7, 8, 9. So this was an answer to that problem, and these were answers. Name the independent and dependent variables, and then the rest of it is our work to show how we got there. I hope you have a wonderful day, and we have one more assignment, and then not too long after that, school will begin.